Have you ever wondered why you exist at all? Well, at the very beginning of the universe, the Big Bang created equal amounts of matter and antimatter. Antimatter is like matter's mirror twin, with each particle having an antiparticle with the opposite properties. Now here's the puzzle. Many rules of physics are symmetrical, meaning they treat both matter and antimatter the same. Yet if these symmetries were perfect all the time, matter and antimatter would have destroyed each other. Why? Well, when matter and antimatter interact, they annihilate as a burst of light. Yet here we are, so how could this be the case? Imagine a small hot room filled with clones of you, that's matter, and their mirror copies antimatter. When they meet, poof, they turn into energy. It's a tiny difference in how they behave. Let one matter clone survive for every billion interactions. Scientists call this tiny difference charge parity violation, or CP violation for short, but really it's just a fancy name for the fact that matter and antimatter might not always behave the same, suggesting that our laws of physics aren't actually symmetrical. Let's look at this example, the electron. It's a building block of the world around us with a negative electric charge and a tiny mass. Now let's look at its antimatter twin, the positron. It has the exact same properties except for positive electric charge. So where do their differences emerge? Well, it has to do with one of the four main fundamental forces of nature. These are gravity, electromagnetism, strong force and the weak force, which is responsible for radioactive decay. Now the first three of these forces treat matter and antimatter the same, keeping our traditional symmetries, but the weak force doesn't. It's ever so slightly biased towards matter in certain particles. Why? Well, in these particles there are even smaller bits called quarks, and how they decay is set by a bunch of probabilities that are slightly biased towards matter. Think of it like a weighted coin that every billion flips shows matter slightly more than antimatter. Could this be why there is something rather than nothing?